Okay, this video is going to be helping you with your homework assignment. So what we're going to be doing here is looking at the different shapes. We've seen before how we have linear relationship, a quadratic relationship, or you can even have a cubic relationship. You guys might be less familiar with what these curves look like. If you have an exponential function, then what the graph of an exponential function looks like is like this. It actually has a horizontal asymptote. Or it can be turned this way, and there will be a horizontal asymptote here. There's no vertical asymptote. And then we have logarithmic functions that have this type of shape. And the ones that we're concerned about are natural logarithmic functions. So when we look for the regression, it's going to be ln for that regression. Okay, so this is your assignment, the printout that says what the department expects from you. So there's a couple of things in here that we just want to go over. So I encourage you to read the whole thing. All of the calculator commands that you need to know are in here. So we have this Saturn IV rocket, and the time starts at liftoff. So if you've ever watched a rocket take off, like one of the big ones, they start the engines first and firing up those engines, and it takes a couple of seconds before there's enough power to where the rocket can actually lift off. So this would be when the engines are started and how much fuel is in the tanks there. So we've got this set of data, and the question is approximate the amount of fuel remaining 500 seconds after liftoff. So what we're going to have to do is put this data into our list, two lists. So it's paired data, and we'll treat these like points, and we'll get a scatter plot. So I need to get a list first. So press Stat, and we got to clear out any old lists. So clear out list 1, second 1, comma, and list 2. Okay, that's done. Now press Enter, and for list 1, we're going to put our time after liftoff data in. And so we're going to have negative 6.4. Make sure you use the negative symbol, not the subtraction symbol. 0, 164, 550, and 700. And then take a few seconds to go back and check that you did it correctly. 99.9% of mistakes made is an error not entering it in correctly. Okay, then we've got our fuel remaining, and notice this is in thousands of pounds, so it's 1626, 1303, 202, 44, and 32. And then again, I'm just going to check. All right. Now we want to get the scatter plot. So press Y equals. If there's any old data in here, clear it out. And make sure your plots are off. I've got a plot on there, so I'm just going to do that. And my plot is off now. Everything's off. So press second Y equals. And now we want to get our scatter plot. So just at the first one there, press Enter. And here we want our plot on for this guy. Enter. Now everything else is to default. The default is scatter plot. The default X list is L1. The default Y list is L2. And I'm going to use this mark. And so all I have to do at this point is to do zoom and 9. Okay, now I can see my points. Okay. And to me that is looking like an exponential. Okay, because it's flattened here at the bottom. Okay, that does not look like a quadratic to me. That looks like an exponential. But as part of your homework, they want you to graph this. And they want you to put the x min and max in the x scale. And what they mean by x scale is they want to know where are the grid marks. And see here, we just have solid. So also, your zoom 9 is going to give you a very nice picture to see these points in, but we need to round things. So we don't need to copy from Zoom 9. And also in this handout, it makes suggestions, okay, for what you can change it to. But let's just press Window. Okay, so first of all, I might make these nicer numbers in that I might make the x minimum, I don't know, negative 100. And the x maximum, how about that could just be 800. And then maybe for the y minimum, we might do, I don't know, negative 250. And for the y maximum, maybe 2000. Okay. Now, what about the scale? The scale is where are the grid marks? And see, if you're going to make 1 unit your grid mark, this is why you have a solid and you can't see the grid marks because that's too small. So if your x max is 800, I'm thinking maybe make the grid marks every 50. And if your y max is 2000, maybe make those grid marks every 100. So it's an individual thing. And you might have to play around with the different grid marks. So then once you've done that, press graph and see if it's nice. That's looking pretty nice. I might see my y scale. Those grid marks look like too close together. So the y scale, the x scale looks nice. The y scale looks pretty close together. So I might just change that to 200. So have a grid mark for every 200 units. And now press graph. I'm liking that a lot better. So you have to play around with these, and you want to get your grid marks here. They're a bit symmetric. That's looking really nice. Okay, and so that's what I would fill in the drawing. You must show the axes. You must draw them in, and with your little grid marks, and then it's easy for you to plot your points. Okay. Once we've done that, you need to make a decision on what it looks like. And as I said earlier, to me, that looks like exponential regression because it's quite flat here, like it's going towards a horizontal asymptote. So I'm going to do Stat, Calc, and I want exponential regression. It's not on the screen. I'm going to keep scrolling down until I find it. There it is. I'm going to press Enter. Because I've chosen list 1 and list 2, that's the default, so I can just press Enter. If you have a newer model, it'll take you to a vertical menu and you scroll down to Calculate. Okay, so if it's asking what is the equation of the line of best fit, or you want to approximate a function, okay, then you're expected to write it. What's the equation that approximates this? You're expected to write it as an equation to at least 4 decimal places. Now, let's be very clear. You must write y equals. If you just write that, the answer's wrong. That's not an equation. So it's y equals a taken to 4 decimal places times b to the x, and we want to take b to 4 decimal places. That's what we're expecting to write down. Now, in the olden days, what we would do, okay, so here it is. All right, so that's the original one, and you want to take it to 4 decimal places when you're giving your answer, what the regression equation is. In the olden days, if we wanted to find the rocket, the fuel remaining 500 seconds after liftoff, well, 500 is x, and approximate the amount of fuel, approximate y. We would just plug 500 into this equation that we wrote out by hand. The department wants you to be more accurate than that. That's pretty darn accurate because I took that to 4 decimal places. The department wants you to use your graphing calculator to the limit that they were done. So here's what we're going to do. We're going to get the calculator to put the original function into a the y equals. We don't have to enter it manually. So here's how you do it. Press y equals, press vars, and then press 5 or scroll down to statistics. I'm just going to press 5. And then scroll over to EQ, and then select regression equation. It's there. And so the latest regression equation that you calculated is going to go into your y equals, going to be defined there. So press enter. There it is. And now if I just press graph, it'll show this curve. Okay. And we were asked to find the fuel remaining 500 seconds after liftoff. So we've been given X and we've been asked to find Y. So I'm going to get the calculator to do that for me. Second trace, and value is what we want, so press enter. And X equals, well, if X equals 500, what is Y? Press enter. And it's giving me the point on the curve with X coordinate 500. Now, look at your original table. The fuel was given as an integer. So I'm going to get my Y value as an integer. So when that's rounded, that will be 69. If you write 69 as the answer, it's wrong. The fuel remaining was in thousands of pounds. So there's 69,000 pounds of fuel remaining. If you write 69,000, the number 69,000 and nothing else, it's wrong. The instructions say write it in a full sentence. So if we write this in a full sentence, what that's going to be is 500 seconds after liftoff, there is approximately 69,000 pounds of fuel remaining in the rocket, or something to that effect. It must be in a full sentence, and it must be, and so here's an example. The rocket had approximately 69,000 pounds of fuel remaining 500 seconds after liftoff. That is what's required. So it has the units, and it's also not 69, it's understood to be 69,000. The second, now what if you'd mistaken this and you thought it was quadratic? So you thought it had a really big butt there and went up like that. Let me press this and clear that out. So what if you thought it should have been quadratic regression? There's the quadratic regression. You'd give that formula, y equals, then with those coefficients to 4 decimal places. Then you'd put it in your calculator exactly. So y equals vars. Then you scroll down to statistics or press 5. Scroll over to eq. Then enter. There it is. And then press graph. All right, that's what you get if it's a quadratic. And again, we have to think about the question. The longer x goes, the more fuel is burned off, yeah? But this is saying you've got all this fuel being burned off, but then somehow you acquire fuel here because the y coordinates are rising. So not only do you have to look visually what fits the data, you have to think about what makes sense. And so the quadratic model doesn't make sense here. Okay. So let me change the x scale back to 1. So whenever you're doing the problem, like when you go on to a different problem, it's going to keep the previous, most recent x scale and y scale. So just be careful about that too. So finally, on a problem like this, the stand age of a forest is determined by, they find the tallest 3 or 4 trees and cut them down and determine their ages, I guess by the number of rings on them. And so the stand age of a forest in years is determined by those tallest trees. So if a forest is a certain stand age, so the older the stand age, the bigger the trees, the bigger the forest, and the more volume of lumber you get. And so we have this data here. And then the question that's posed to us on this is, what's the volume, approximate the volume of lumber in a stand that is 150 years old. So this lumber company has purchased some land, and it's been determined that the stand age of the forest on the land they've purchased is 150 years. And so they want to know, what is the volume of lumber in cubic meters per hectare can we expect? And we don't want to look at the graph and then say, oh, well, this is going to be, I guess, around 300 maybe, if you're just guessing, because, you know, 150 is a little bit less than 160. We don't want that. We want to be as accurate as possible. So, again, we're going to put that into our calculator. So, second mode. But before I do anything, I have to clear out my old lists. Second 1, comma, second 2. And now I'm going to go into here, and I'm going to put my x values. So scroll over to list 140, 80, 120, 160, 200. And I'm just checking to see that, double checking, see if that's correct. Then 92.4, 193.9, 265.3, 317.1, and 350. And again, I'm just going to double check. Okay, I'm good to go. I want to look at the scatter plot. So press Y equals. Any old data in there, clear it out. Then turn your plots off. Enter. So I can see nothing's highlighted, my plots are off. Press second, Y equals, and just select the first one. We want the plots on for this guy. Now everything else is default. The default is scatter plot. The default for the X list is list 1. Default for Y list is list 2, which we've chosen. So I'm just going to do a zoom 9. Okay. Again, we could be forgiven for thinking that that could be quadratic. Okay. But I think it looks logarithmic. I think it's more logarithmic. And remember, as the stand age, the older a stand age is, the bigger the trees. So the more volume you're going to have. And if that were quadratic, then the bigger the trees at some point are going to be less, and that's not going to make sense. Okay. So I think that's a natural logarithmic function. We only deal with natural logarithms here. And so that's what I want, is natural logarithmic regression. So remember, we use the LN key for natural logarithms. So, but before I do that, I need to get this in the best window possible. The department requires that you sketch in the axes, the x-axis and the y-axis. And so press window. Well, for that to be true, you're going to have negative values for x and for y, and you don't. The axes are not in this window. So I'm going to do something like maybe negative 50, and then maybe take x max to 250, and my y minimum, I'm going to do negative 50 for that, and take my y max to 400. And let's just press graph. Okay, that's a bit better looking. Now let's get a scale in. X minimum goes from negative 50 up to 250. Well, I could take it by 50s, but I think that's going to make the blocks too big. The chunks, the grid marks. Let's just see. Yeah, I'm going to change that to 25. So again, it's the type of thing where you look at that. I think looks better. And then what about here? Now the y's go from negative 50 up to 400. I might do the y scale at 50. That looks really good. Okay, so that's the picture they want you to draw. And those are your x-min and x-max. So we've got nice whole numbers there to deal with. Okay, so that should make everybody happy. Now I said that I thought that this was logarithmic regression, but it's natural logarithm. Natural logarithm is ln. So I'm going to go to Calc, and I'm going to find ln regression. Not linear, ln regression. That's what we want. Don't confuse it with anything else. Do not get that. Logistic, that's not logarithmic regression. We want natural logarithm regression, ln regression. So that's number 9. Press enter. And of course the default is list 1 and list 2. So if you have one of these older models like I do, you just press enter. I want to put that in my calculator. Y equals vars. Then we want to scroll down to statistics, or just press 5, scroll over to EQ, and then press enter. There it is. Now, if they want to know the equation, you take the equation to 4 decimal places. So what is the equation of the curve of the regression function, or the regression equation? That's what you write to 4 decimal places, but you won't be using that calculation. We fixed it to where the exact equation is in our calculator. So finally, what is the volume of lumber in cubic meters per hectare expected if the stand age of a forest is 150 years old? So if X is 150, what is the Y value going to be? So let's press graph and let's see how that fits. That's fitting nicely, isn't it? And so if X is 150, what is the Y value? So I'm going to do second trace. And I'm going to press enter. And if X is 150, then press enter. What's the Y value? Okay, now, before you do anything else, the volume of lumber in that table is all, well, you can argue that that's 350.0. They're taken to 1 decimal place. So unless you're given instructions to do otherwise, you'll take your answer to 1 decimal place. So to 1 decimal place, that's 302.8. So if the stand age is 150 years, I would expect 302.8 cubic meters per hectare volume of lumber. And so write your answer as a complete sentence. The volume of lumber in a 150-year-old stand of trees is approximately 302.8 cubic meters per hectare. Okay, so I leave it to you to look at the rest of these problems, but I wanted to make sure I went through one that was logarithmic and one that was exponential with you for this video.